right, we're going to finish section 14.5 right now. We are on the point where we're about to do some conversions with grams and tons and things like that with volumes. So let's get there. Here we are. All right, so the first example that we're asked to do is to convert 3689 grams into metric tons. So if you take a look, this number of grams actually has a relationship between tons and grams with kilograms. So take a look over here. Here is our, where is it? There it is. Our tons to 1,000 kilograms. So we're going to take our value in grams and turn it into kilograms. So first of all, the 3689 with King Henry died by drinking chocolate milk. I'll just write it up here again. We're going from grams, which is our base unit, over to kilograms. So it's 3 decimals to the left. So here's 1, 2, and 3. So we have 3.689 grams, and we're wanting to turn that into tons. And the relationship we just saw was that 1,000, let me put the kilo in there, sorry, kilograms is equal to 1 ton, and it's a metric ton. So we are going to be able to take the 3.689, divide by 1,000, which will be the equivalent of moving the decimal again 3 to the left. This is 0.003689 metric tons. I'll even maybe going to write metric just to not confuse them with the other types of tons we have. All right, the next two ask us to complete the following relationship. It says 1 cubic meter of water has a capacity of 1 what? So we're looking for cubic meters of water. So if you take a look at this, we can talk about different relationships between cubic meters and other types of metric measurements in cubes. So in particular, if you looked at decimeters, and the reason I'm thinking that decimeters might be useful is because here we have decimeters cubed, centimeters cubed, and decimeters cubed is a closer relationship than the centimeters cubed. So 1 meter cubed is the same thing as 1,000 decimeters cubed. And according to that relationship over here, that's equivalent to 1 kilogram and 1 liter. There you go. So 1 decimeter cubed is equivalent to 1 liter. Oh, I'm sorry. I wrote that too quickly. 1 decimeter cubed is equivalent to 1 liter. So since this is the same as liters, the same relationship would follow with it being 1,000, 1 to 1, so this is 1,000 liters. And 1,000 liters is the same thing as 1 kiloliter. So this is 1 kiloliter of water. So that's capacity. Capacity has to do with liters, right? And then mass has to do with grams, the relationship. So we're going to do the same thing. The 1 cubic meter is 1,000 cubic decimeters. And the decimeter, for liters it was 1 liter. And for kilograms it's 1 kilogram. So since this is kilograms, it would also be 1,000 kilograms. And if I change that and take a look at that relationship, let me look at the other table over here. We had kilograms. The kilogram, 1,000 kilograms, is equal to 1 metric ton. So 1 T. This is 1 ton, or 1 metric ton if you prefer. Example number 9 talks about actually finding a quantity. So this is an Olympic-sized pool in the shape of a right rectangular prism. If it is 2 meters deep throughout, how many liters of water does it hold? And it says it's a right rectangular prism. So we're going to try and draw this. No promises on it looking, super good or anything, but this is a rough estimate. We're going to have a length, width, and height. It says it's 2 meters deep throughout, so that's this distance. It's 50 meters by 25 meters, so we'll call this the 25, or flip them around, and this one would be my 50. And we want to know how many liters of water that is. Well, the first thing we can find is we can find how many cubic meters it is. So the volume is 25, so length times width times height. 25 times 50 times 2 for a total of 2,500 cubic meters. And again, what we just did on this problem before over here with cubic meters is we changed them into decimeters. So we'll take that 2,500 and move 3 more decimals. So that's 3 more zeros. So this is 2,500,000 decimeters cubed. And the decimeters cubed is the same thing as a liter. So this is that many, 2,500,000 liters. All right, the last thing we have to do in this section is temperature. So taking a look at some temperature information, the base English unit for temperature is a degree Fahrenheit. The Fahrenheit scale divides the temperature range from freezing at 32 degrees to boiling at 212 degrees into 180 equal parts. And of course, we all know that the 180 is coming from half of a circle, degrees of a circle, things like that. In metric, the base metric unit is the degrees Celsius, and the Celsius scale goes from freezing at 0 degrees to boiling at 100 degrees into 100 equal parts. Of course, this is the metric system, so it should be no surprise that we're doing things in a base 10 way. The metric temperature unit Kelvin is another type of unit. It's used primarily for scientific measurements. It actually has an absolute zero, like there is no temperature that is below 0 degrees Kelvin. And the freezing point then of water in Kelvin is 273.15 Kelvin, and the boiling point is at 373.15. Some common temperature values that you should be aware of. We mentioned the boiling point, of course, being 100 degrees Celsius, 212 degrees Fahrenheit. Freezing being 0 degrees Celsius, 32 degrees Fahrenheit. Having some of these measurements sort of, I don't know if you want to say committed to memory, but at least being able to reference them fairly easily. It's probably not a bad idea. 98.6 degrees Fahrenheit is your normal body temperature. That's about 37 degrees Celsius. If you've got a warm day out at 77 degrees Fahrenheit, that's about what it is outside today. That would be about 25 degrees Celsius. Room temperature, 68 degrees Fahrenheit, would be about 20 degrees Celsius, and so on. So these are good reference points as you're thinking about common temperatures. And the last thing we're going to do is we're going to take a look at converting temperatures. So to convert back and forth between Fahrenheit and Celsius, we use the following equations. So Celsius is equal to 5/9 Fahrenheit minus 32 degrees. And if we manipulate that and solve for Fahrenheit, Fahrenheit will equal 9/5 Celsius plus 32 degrees. I want to draw your attention to a couple things about these formulas. Notice the Fahrenheit minus 32 degrees in the first equation is in parentheses and then it's multiplied by the 5/9, whereas the multiplication occurs first in the other equation and then the addition afterwards. Those are common mistakes for people to make, is to convert them with the parentheses basically in the wrong location. All right, so what we're going to do now is we're going to actually take our 40 degrees Celsius and find out what that would be in Fahrenheit, because, 40 degrees Celsius doesn't sound very hot. I mean, it's 40. And in Fahrenheit, of course, we know it's not. So let's see what that actually is, though, in degrees Celsius, in Fahrenheit. The 40 degrees Celsius is in Fahrenheit. So we're going to take our equation that's Fahrenheit equals 9/5 Celsius plus 32. And we're going to plug in what we are given. We are given 40 degrees Celsius plus my 32. If I plug that into my calculator, I will actually end up with 104 degrees Fahrenheit. That's like, the maximum temperature for a hot tub, basically, that you're looking at. So 40 degrees is a pretty warm temperature. You're not going to want to go snow skiing in that or running outside in that degree.